Hello science fans, let's talk about something big. I mean, really big. Think about the massive metal structures that make our world work. Giant ship hulls, towering bridge beams, colossal industrial press frames. These structures are made by welding, casting, machining huge pieces of metal together. But this process leaves behind a hidden problem. It's an invisible force locked deep inside the metal itself. We call this force residual stress. It's like a tightly coiled spring trapped within the steel waiting for a chance to release its energy. This stress isn't from the weight the structure carries, it's a leftover from its very creation. Imagine you're building something with clay. As you shape and form it, you push and pull the material. When it dries, some parts might be more compressed than others. Metal behaves in a similar way, but on a much grander scale. When a welder joins two thick steel plates, the intense heat causes the metal to expand rapidly. As it cools down and shrinks, it pulls against the surrounding colder metal. This internal tug-of-war creates locked-in tension and compression zones. What happens when that hidden residual stress finally gets out? The results are never good. Over time, these internal forces can cause tiny microscopic cracks to form, especially in high-stress areas like weld joints. At first, these cracks are too small to see. But with every cycle of use, the stress opens and closes these tiny fissures. Example: a heavy truck crossing a bridge. Example: a press stamping parts repeatedly. This process is called fatigue. Slowly but surely the cracks grow larger, like a small tear in fabric that worsens each pull. Eventually one crack can reach a critical size. When that happens, failure can be sudden and catastrophic. A bridge collapses. A pressure vessel ruptures. A giant wind turbine gear shatters. These failures are dangerous and costly. They put lives at risk and halt operations, costing millions. Parts meant to last decades can fail in years from unseen stress. It is a serious problem with serious consequences. Even without total failure, residual stress causes major headaches. So, how do we get rid of this pesky stress? There's a brilliant and elegant solution: vibratory stress relief, or VSR. It sounds complicated, but the idea is actually quite simple. We shake the stress out. We use controlled vibrations to gently relax the metal at a microscopic level. In a modern workshop, you'll see a VSR system in action. A powerful, precisely controlled vibrator motor clamped directly onto the metal structure. Sensors monitor how the structure responds. A high-tech, straightforward process. Here's how it works. The system starts vibrating, sweeping through frequencies to find its natural resonant frequency. Like pushing a child on a swing at just the right moment. At resonance, vibrations create uniform low-level dynamic stress across the workpiece. That rhythmic shaking lets atoms in the metal lattice shift and settle, a deep tissue massage for metal. This breaks down peaks of residual stress. Energy from vibrations lets locked-in stresses redistribute more evenly. High stress zones relax and internal tension drops. For many decades, the go-to method for relieving stress was heat treatment, also known as thermal stress relief, or TSR. The process is simple in theory. You put the big metal part into a giant oven, heat it up to a very high temperature, still below its melting point, let it soak for several hours, and then cool it down very, very slowly. This lets metal atoms rearrange and release locked-in stress, but it has major drawbacks we can't ignore. First, heat treatment uses enormous energy. Heating a 50-ton structure to over 600 degrees Celsius, about 1,100 degrees Fahrenheit, and keeping it there for hours needs a massive furnace and burns a lot of fossil fuels. That makes it costly and bad for the planet. VSR uses a tiny fraction of that energy, about the same as a household appliance. Because VSR is portable, you can treat the structure on the factory floor, saving time and transport costs. So let's sum it all up. We know that large metal structures, the backbone of our industry, contain hidden residual stresses from the moment they are made. These stresses lead to cracks, distortion, and catastrophic failures that are dangerous and honestly incredibly expensive. For years, the solution was massive, energy-guzzling furnaces for heat treatment. But today, we have a smarter, more elegant solution. Vibratory stress relief uses controlled vibrations to relax the metal from within, neutralizing the hidden threat of residual stress without the high costs, environmental impact, or negative side effects of heat treatment. It's a game changer. The benefits are clear. VSR is energy efficient, saving companies money and reducing their carbon footprint. It is fast, cutting down treatment times from days to mere hours. It is portable, allowing for on-site treatment that eliminates transportation logistics. And most importantly, it is highly effective, producing dimensionally stable parts that are more resistant to fatigue and have a much longer service life. By adopting VSR, we are not just improving a manufacturing process. We are building a safer, more reliable, and more sustainable world. The proof is in the data. Stress distribution maps provide undeniable visual evidence of VSR's power, showing how chaotic high-stress peaks are smoothed into a calm, stable state. For consultation and state-of-the-art VSR solutions, contact the experts at Don Technical University today and be part of the vibration revolution.